Good morning all. This is Desh Kumar, Assistant Professor of EC Department. Now let us see the another video lecture series on properties of Z transform. Z transform is used for analysis of discrete time signals. It is more broad compared to discrete time Fourier transform. It is very much useful in discrete time signal as well as system analysis. X of and X of Z forms the Fourier transform pair. This is the ROC representation of Laplace transform and Z transform. Z transform can be defined as x of z is equal to summation n is equal to minus infinite to plus infinite x of n into z power minus n, where z is a complex variable, z is equal to r into e power j omega. Therefore, which is inverse Z transform can be defined as x of n is equal to 1 by 2 pi j integral over x of e into v power n minus 1 into dp. Next one, it is the types of Z transform. It can be classified into unilateral or one-sided Z transform. X of Z is equal to summation n is equal to 0 to infinite x of n into Z power minus n. Bilateral or two-sided Z transform. X of Z is equal to summation n is equal to minus infinite to plus infinite x of n into Z power minus n. ROC is the region where Z transform converges. The Z transform is an infinite power series. Significance: ROC gives an idea about values of Z for which the Z transform can be calculated. ROC can be used to determine the causality and stability of the system. This is the basic discrete time signals. Unit step signal U of n is equal to 1 for n greater than or equal to 0, 0 for n less than 0. Unit impulse signal L of n is equal to 1 for n is equal to 0, 0 for n should be not equal to 0. R of n can be defined as n for n greater than or equal to 0, 0 for n less than 0. This is the graphical representation of some basic discrete time signals. Next one is a transform unit circle ROC. This is unit circle. A should be greater than means outside the circle, the ROC. Unit circle 1 divided by A less than 1 means the inside the circle should be the ROC. A should be less than 1 means the second circle, first circle outside of the first circle is the ROC. When the units are 1 divided by A less than 1 means the inside the two circles is the ROC. Unit circle ROC. When x of z divided by z minus a, when modulus of z should be greater than a means outside the circle of the one, a is nothing but the ROC. When x of z is equal to z divided by z minus a, when modulus of z should be less than modulus of a means inside the circle of a representation is nothing but the ROC. Next one, properties of ROC: proper linearity, time shifting, time reversal, scaling into Z domain, time expansion, convolution, conjugation and differentiation in Z domain. When x1 of n pair with x1 of z, x2 of n pair with x2 of z, a into x1 of n plus b into x2 of n is a transform pair with a1 into a into x1 of z plus b into x2 of z. Now we can apply in the formula n is equal to minus infinite to plus infinite a into x1 of n plus b into x2 of n into z power minus n. Now we can substitute the values a into n is equal to minus infinite to plus infinite x1 of n into z power minus n plus b into summation n is equal to minus infinite to plus infinite x2 of n into z power minus n. Finally, we can get a into x1 of z plus b into x2 of z. Next one, time shifting. X of n is a transform pair with x of z. Then x of n minus 1 is a transform pair with z power minus m into x of z. Therefore, instead of x of n, you can substitute x of n minus n. N minus m is equal to p. Therefore, x of p is z power minus of p plus m. Therefore, z power minus m we can take it as common. P is equal to minus infinite to plus infinite x of p into z power minus p in terms of x of z. Therefore, z power minus m into x of m. Next one, time reversal. X of n is a transform pair with x of z. Then x of minus n is a transform pair with x of 1 by z. Now we can substitute n is equal to minus infinite to plus infinite x of minus n into z power minus n. Minus n is equal to p. Therefore, p is equal to minus infinite to plus infinite x of p into z power p. Therefore, which is equal to p is equal to minus infinite to plus infinite x of p into z inverse of the whole power minus p. Therefore, x of z inverse can be represented as 1 by z. Next one, scaling in Z domain. X of n is a transform pair with x of z. Then z z naught, z bar n into x of n, z transform par with x of z divided by z naught. Therefore, z naught of x of n into z bar minus n. Therefore, x of n is equal to minus infinite to plus infinite x of n into z divided by z naught the whole bar minus n. Therefore, capital X of z divided by z naught. Time expansion, x of n is a transform par with x of z, then x of m into n is a transform par with x of to z par m. Therefore, x of m into n into z par minus n, which is equal to x of n by m into z par n by m is equal to r, which is equal to x of r into z par minus into mr. Therefore, x of r into z par m into minus r. Therefore, x of z par m. Next one, convolution, x1 of n into x2 of n is a transform par with x1 of z into x2 of z. Therefore, we can get substituting the formula, m is equal to minus infinite to plus infinite, my m into first infinite to plus infinite, x1 of m into x2 of n minus m into z par minus n. Now we can take it as common, m is equal to minus infinite to plus infinite x1 of m, n is equal to minus infinite x of n minus m into z par minus n. Therefore, we can get x2 of z into x1 of z. Therefore, x1 of z into x2 of z. This is nothing but convolution property. X of n is a transform par with x of z, then x conjugate of n is a transform par with x conjugate into z conjugate. Now we can substitute x conjugate of n into r par minus n into e power minus j omega n. Therefore, x of n into r par minus n into e power j omega n. Therefore, n is equal to minus infinite to plus infinite x of n into z conjugate into the whole par minus n. Therefore, x into z conjugate into whole conjugate, which is equal to x conjugate into z conjugate. Now we can get the ROC of left hand sided sequence. We can get the differentiation property, x of n into d by dz into z par minus n, minus of n into x of n into z par minus n minus 1. Therefore, minus z into d into x of z divided by dz, which is equal to summation n is equal to minus infinite to plus infinite n into x of n into z par minus n. Next one, we can see the applications. It is used to analysis of discrete time systems. It is used for digital signals. It is used to solve the difference equation with constant coefficients, to characterize the transfer function of discrete time LTE system, to design a digital filter. Now we can see the assessment. Define Z transform. X of Z is equal to summation n is equal to minus infinite to plus infinite x of n into z par minus n. The unit step function is given by x of z is equal to z divided by z minus 1. List the properties of Z transform: linearity property, time shifting, frequency shifting, convolution property, conjugation property, and then scaling in Z domain. ROC of Z transform can be used to determine causality and stability of the system. State linearity property of Z transform when x1 of a into x1 of n plus b into x2 of n is a transform par with a into x1 of z plus b into x2 of z. Z transform is used for analysis of discrete time signals. Determine the property of the Z transform. X1 of n into x2 of n is a transform par with x1 of z into x2 of z is nothing but convolution property. Thank you.